Hello guys, welcome back to my channel Learn with PR. In today's video, we will be understanding how to calculate time and space complexity. So first of all, what is time complexity? So time complexity tells us how the running time of an algorithm grows as the input size increases. So whatever the amount of time your code is taking to execute some task and you can say operation, that you can say time complexity. All right. Now let's talk about what is space complexity. The space complexity basically tells us how much extra memory an algorithm uses apart from the input. So we should not taking care of input, right? We just need to take how much extra memory an algorithm taking in your code. All right, that you can say the amount of space, you can say the time complexity. All right. So now here I have share a different complexities here as big O one, big O log n, big O n, big O n log n, big O n square, big O n power 2 power n. All right. So these type of complexities you have. So when we have big O one, that time you should know that's a constant actually. And we have examples written here as well, right? So big O log n is a logarithm. Linear we have big O n. Linear log n we have n log n. Quadratic we have n square, and 2 power n we have exponential. All right. So first of all, you should know when you are finding complexity, that time you have to measure with the help of big O. All right. So whatever time complexity you have and space complexity you have, that time you will say it obviously calculate with the help of big O. All right. So these are the meanings and examples I have written. So we will see in the next slide that how we can calculate it. One by one, we will check all things. Okay. So now let's start. So here the first example I have written here int x having value as a of 5. Okay, so a is an array name and 5 is an index size. So a5 may, if suppose the value is 20, so x will get a 20 value. All right. So as I told you, how we can calculate time complexity. So whatever the operations I have discussed already that point, okay, in my previous video, you can check it. I will give the description. I will give a link in the description. Okay. All right. So how many operations you are performing in your program and it's taking how much time. All right. So that we can say time complexity. All right. This is how we can say it. Okay. And then how much extra space you are asking from your compiler or asking from your computer. All right. That you can say space complexity. So for this time complexity, we are simply writing one operation here. We are simply printing one operation, that printing, right? So only one operation we are doing, and input side doesn't matter here actually. All right. So the time complexity become big O one. All right. There is only one operation now. Okay. So that time complexity become big O one. What about the space complexity? This is a array actually. Okay. So you have already taken the input. So as I have discussed already in this point, how much extra memory an algorithm taking is apart from your input, whatever input you are taking, we don't need to consider it actually. All right. Apart from that, extra memory, how much we are taking, okay, that we can say space complexity. So only one variable is there, okay, x. So it's a constant, now one variable. So we will say space complexity become bigger one. All right. Now let's talk about the next example. So linear time we are saying. So now here we are saying I is getting 0 value and it's taking a condition as I smaller than n and it's going to print a of I value. Okay, and it will increase, it will check the condition, it will print, it will increase the value of I, right? It will check the condition and then print the value. All right. So how many times you are saying that I am printing a of I value? So how many times you are saying n times we are going now. So time complexity will become what? N, big O N. All right. So you can say how much whatever the condition you have, you just need to check it. Okay. How many times it will go, you have to just take care of. So loop runs n times. So that means if the operations are n is 5, so 5 operations will be there. Now if 1000, then 1000 operations will be there, 100 operations will be there. So as growth is directly proportional to your n. So whatever n value you have, that will be the time complexity. So we will say big O n time complexity it will be. Now what about the space complexity? What about the space complexity? A of I is a what? A is a array name. So you are taking array as an input. Okay. But I told you space complexity में हमारा input size matter नहीं करता है. Okay. So what we have to check? We have to check what is I. So we are only having one variable, loop variable we'll say. So no extra space reused here, right? So we'll say space complexity become big O one. So only you will say here as big O one. Okay, space complexity as well as time complexity. Sorry, time complexity become big O n and the space complexity become big O one. Why? Because there is only one variable we are using, that's I. Okay, no extra space used here. Okay, that's how we can say the example of linear time. So I hope you understand this example one, example two. Okay, if you have any doubt, please write in a chat box. Okay, now next example we have here this. So can you say what is this basically? Anyone write in a comment box, chat box, please. Okay, so what I'm saying, this is I equals to 0, I smaller than n, and it's going checking every key. What is this program basically? Anyone write in a chat box. So if I'm saying I'm checking I from 0 to n, so how many times your code is working? How many times? It's going n times. Log, you can say big O n times you are going. Okay. And what variable you are taking? How many variables you are taking? A to input hai, you know very well, right? I we have, key we have. Okay. So only variables are using. So it will take a space as big O1 only. Hai na? It will take a space as big O1. So this is the program of your linear search actually. Okay. So this is the program of your linear search, a simple one. So your program is taking how many times, means how many times your for loop is working, n times your for loop is working. Okay, so big O n it will take. If you are saying ki first element I want to search, that will become the best case, big O 1 time it will go. If you are saying I'm checking for the last element, okay, that time your worst condition will be there, that you can say big O n. Okay, we consider worst case also, right? So we will consider from these, actually we have to consider the worst case, the greatest value, you can say the greatest between among these two is big O n, you can say. So time complexity become big O n, and space complexity again big O 1. Why? Because there is no extra space you are using, only variables are there. Okay, so when you are taking variables, that time you have to consider big O 1 only. Okay, all right, I hope you now understand this example 3, how we are saying time complexity is big O n and space complexity big O 1. Now let's talk about this nested looping. So when you are saying you have a nested looping, that means you have I and you have j, and they both are going till your n. They both are going, na, I smaller than n, j smaller than n. So how many times your inside loop will work? N times. How many times your outside loop will go? N times. So n multiply by n, you can say it will become big O n square time complexity. Okay, big O n square time complexity. Here you are taking variable as I and j only, so they are simple variables, so that the space complexity again become big O 1. All right, so this is a nested loop actually, where you will say outer loop will go n time, inner loop will go n time. So now total operation become n square, n multiplied by n square. So time complexity become n square. So obviously you know very well that point, that your nested loop will go till your condition become, है ना, your condition, if it will stop there when the condition become false. Okay, so the condition will become false till n, after n. Okay, so this is how we can say. Okay, time complexity is n square and space complexity big O 1. Okay, now let's check the next example. So here I have written a simple code for you. Can you write in a comment box that what is this program basically? What is this program? We have already discussed that point also. You can check the previous video also of mine. Okay, so this we say it's going low is smaller than equal to high, and we are doing mid equals to low plus high divided by 2, and we are checking a mid value. If we are getting in, then we will print it and break out, and then the condition is, if it is not true, then here we have to check the condition, and else it will go here. So this is a binary search actually. So binary search divides in a two parts. So when we are dividing in a two part, that means what? We are skipping some iteration ना, हम skip कर रहे हैं ना, कुछ ना कुछ iteration हम skip कर रहे हैं. अगर हमारे पास 10 element है, तो we are checking the middle element, then we have to check that left side or right side we have to go. Okay, this is how we are doing. So we are skipping one part actually of your array, है ना, हम कुछ आधा कर दे रहे हैं. अपने 10 थे तो 5 ही हम सर्च कर, 5 ही में हम एलिमेंट फाइंड कर रहे हैं. देन 5 बचे तो उसको आधा डिवाइड किया, 2 ही एलिमेंट्स हम देख रहे हैं. ठीक है, लाइक दैट वे. So we have to say what we are, whenever we are skipping some iteration, जब हम iteration को skip करते हैं, that time we'll say the time complexity become big O n. Sorry, big O log n. That time our time complexity will become big O log n. Okay. So we are going step approximately, you can say log n time only. So the time complexity become log n. When we are skipping some iteration, that time we'll say log n will be the time complexity. What about space complexity? A is the input variable. Okay, we are taking low, high, mid, है these key we are taking. So these are the variables now. So it will obviously take what? Big O 1 time. Big O 1 space complexity. All right. So if you have any doubt in this, please write in a comment box. So now next example I have written here a mixed complexity. Now how we can say it? So this is a for loop, one for loop. It's here actually. Okay, this is one for loop, and this is another for loop. Okay, है ना? This is one for loop. So what will be the time complexity for this for loop? That's, you are saying, ma'am, it's going n time. So n big O n, right? So the first loop is a big O n. But what about this? This is a nested actually. So it will say I will go n time, I will go n time. So n square will be there. So next loop will be the n square. Now you have to say which one is greater. N is big O n is greater or big O n square is greater? Big O n square. So we have to take the dominant term, you can say, and that is the n square. That's why we are saying time complexity become n square. What about the space complexity? This A is a input variable. You are taking a input array. We have A, right? We have I, we have J, we have N, whatever. So these are the variables only. Okay, these are simple variables. So we will take the space complexity as big O 1. So there is no additional memory you have to use. There is only loop variables, nothing else. Are you getting a point? So this time complexity for this for loop is n, this for n square, okay, and which one is greater among these two? That's n square. So we have to take time complexity as big O n square, and the space complexity big O 1. Okay. Now next check this program. So next program says what? This is a function. We are saying this is a simple function having fun, and inside it we are having n. But here we are again calling function. We are calling simple this function again. है ना? Inside it until unless the condition become false. Okay. So this you can say recursive function. No, it's calling again itself. है ना? Calling itself again. So if the condition become false, then it will jump out. It will return. Okay. But thing is, it's going as fun here, right? It's going n times here, but here it's dividing by 2. So when you are skipping some iteration n divide by 2, that means what? That means what? Your time will go n first. पहले वो n में जाएगा पूरा. फिर n square n divide by 2 हो गया, okay. Then again it will do n divide by 4 now. Again it will go n divide by 8. Again it will go n divide by 16. N divide by 32. Like that way it will go now, right? So number of calls will be the approximately big O log n. Right? How many time it will call? Big O log n. So the time complexity will become the big O log n because you are skipping some iteration because you are dividing by 2. When you are dividing by 2, that means n, if you are saying n is 50, okay? So it will divide by 2, then n become what? Here n become what? 25. 25 divided by 2, then n become what? 12.5. 12.5 because we are taking integers, so 12 it will take only. So 12 time n value become 12. So half ho ja raha hai. Are you getting your point? So when it's going half, you can say log n will be the time complexity. All right. What about the space complexity? I have discussed already recursive function, how we can say the time and space complexity for it, right? We have already discussed that part in my previous video. Please check binary search and how we can calculate time and space complexity for binary search also. So you can check it there also. All right. So the space complexity, whenever you are restoring, you are calling, every time you are calling your function, you are calling function here also, and then again it's calling again itself, right? It's calling itself again. Okay. So when it's calling, then your call stores in a stack actually. Okay. So your call stores means आपका एक stack बन जाएगा कि how many times you are calling your function. So it will store in the stack. Okay. So it will again go log n time. Log n. It will take maximum depth, as you can say, approximately to your log n. So the space complexity again become big O log n. Okay. So this concept I have already discussed. I hope you watched that video. Okay. So I'm not going in depth in this. Okay. Now next, single loop with condition. So here I have written I from 1, I starting from 1, and it will go n times. Okay. Okay. Hai. But we are saying I value we are printing. So first it will print 1 value. Then I become I equals to I multiply by 2 actually. So 1 multiplied by 2. So I become 2. So 2 is smaller than n 10 times, suppose you are saying. So 2 will print. Now 2 multiplied by 2, 4. So are you skipping some iteration here? Yes, 3 is not there. 3 नहीं आया. ठीक है. And जब 3 हो जाएगा आपका I 2 multiplied by 2 become 4. I become 4. 4 is smaller than 10. Yes, 4 will print. Then 4 multiplied by 2, that become 8. So there is 5 nahi aaya, 6 nahi aaya, 7 nahi aaya. So you are skipping some iteration again, right? That time you will say you will have I value is 1, 2, 4, 8, 16 like that way, right? If you are having 10, so 16 will be not there. If n is 50, then it will go like that way, okay? So your program, your loop, you will say having as log n times running actually, okay? It's running n time, log n times. So the time comes to become log n, okay? Now here you are using ni. These are the simple variables, okay? So you will say the space complexity become big O n, big O 1, okay? Okay, all right. Now two independent loops here. We are using one for loop. Okay, here one for loop here. So what is the time complexity for this for loop? This n, because it's going n times. It is also going n times. So both are n times. So who is greater? Nobody is greater. You can say add it. When you will add it, you will get 2n. So 2 is a constant, remove it. Okay, so you can simply say when you will total it, you will get big O n. So 2, whenever constant are there, you have to ignore that constant. Okay, so here we have big O n. But when we are checking about the space complexity, all right, so that space complexity, you will say there is no extra variable you are taking, there is simple loop constant loop variables, so you will say big O 1. Okay, now next program we have loop inside loop. So when we have loop inside loop, but here I going till n, but here j is going as I the value is. Okay, whatever the I value is, it's going, j going that only. So what is it? So here you will say this having n square, sorry, this having n for loop, for I wala will go till n time, but inner will go till your I value. So if I is 1, sorry, if I is 0, so it will go 0 times, so 0 is there. But when I is 1, so it will go 1 time. When I is 2, it will go 2 times. Your j will go 2 times, no? So you will add in a loop like this way. And I believe that you have done this thing in your maths also. So when you will calculate it, now you will see the total operation is this. You will, when you will, simply what, that when you will simplify this program, this thing ना, that series, this is a series something, right? Maths में series होती है. So जब आप series को solve करोगे ना, you will get this, right? So when you will get this, that means what? This n is here you are writing, and this is the n divided by n minus 1 divided by 2. Okay, when you will calculate it, you will get n square something, n square minus n है ना, divided by 2. So who is greater, कौन सा आपका greater value है? So n square है ना, so you are taking time complexity as n square. Okay, big O n square. What about the space complexity? There is no extra space you are using, so space complexity become big O 1. Okay, I hope you are getting this program. If you are have any kind of doubt, please say. Okay, I will solve that query. Okay, now next we have here loop, and we have extra variable also. So here we are saying we have sum, we have I equals to 0, I is going till n time. That means what? Your space complexity is, sorry, your time complexity is big O n. Okay, but you are having another extra variable also, right? So it's okay, whatever variables you are taking, you are having n times of variable, that n variables you have, that is also okay. So here also space complexity become big O 1 only. जब भी आप वेरिएबल ले रहे हैं ना, कितने भी वेरिएबल ले सकते हैं आप, ठीक है, दैट स्पेस कॉम्प्लेक्सिटी विल रिमेन सेम, big O 1. But if you are taking extra array, that is not okay. Extra array you are taking, array ka whatever the size is, that will the space complexity. Okay, chalo, let's talk about 2D array. So here you have 2D array, that means n means number of rows and number of columns, suppose. All right, so your time complexity for this is 2 times it's working n, so n square will be there. Or ma'am, if we are saying this is m, है ना, तो n multiply by m, it will be the time complexity. Okay, but what was the space complexity? You are taking input as n square, means 2D array size will be n multiplied by n. That means the space will be taken as big O n square. All right, so here this is change in this. Okay, in 2D array and 1D array was 1D array method, it was just ignoring the number of elements, but here is a n 2 times actually. Okay, that's why we have to take space complexity n square. All right, okay, now next we have this factorial function. So factorial function, again your factorial is going till n. Okay, n is 0, suppose when n is 0, that time it will simply return 1. But if n is something, n 50, 20, 30, 40, whatever, that time you have to multiply n with the factorial n minus 1. Again this function is calling itself. Okay, but this time we are not doing any half. कुछ नहीं कर, हम half divide by 2 तो नहीं कर रहे हैं. We are not skipping any iteration. So my this program will take how much time complexity? N time it will call. Na? Your function will call n times. Na? So you will say n times. So big O n. Okay, big O n will be time complexity. What about the space complexity? As we are saying in a recursive function, recursion may what will be the stack will take care of. Stack may how many times you are calling your function, it will store. So when it stores n times, so yes, n times. Earlier was the log n times. Why? Where it was? This we are talking. So here n divided by 2 was there. No? So n by 2. So means we are skipping some iteration. Okay, that time we are saying log n. But in this basically, we are not dividing by 2 actually. We are not skipping any iteration. It will go n times. Okay, so time also big O n, space also big O n. So n times your stack will store that values. Okay, so big O n times it will go. Now recursive with 2 calls. Suppose you are calling 2 times same function itself again. So how many times you are saying? Means you are saying here n time, means integer n hai, right? It's saying just reduce by 1. Here is also reduced by 1. So how many times you're saying? So here each call makes 2 call actually. जितने बार आप फंक्शन को कॉल करोगे वो 2 बार कॉल करेगा ना. एक बार आपने फंक्शन कॉल किया तो ये 2 बार 1 and 2 times you are calling, right? So as time grows exponentially, so that time complexity become 2 power n. So whatever n value, it will be 2 power n. That n is 50, so 2 power 50 will be there. Okay, but your space complexity, it stores n times now, so log, sorry, then the space complexity become big O n only. Okay, I hope you now getting this concept where we have to take log n, where we have to take n, where we have to take 2 to the power n, right? So this how we can say. So 2 times we are calling, that's why we are not calling no one by one, we are calling together actually. That's why we are saying 2 power n. Here also 1 minus हो गया. Now इधर भी minus, suppose यहाँ पे n की वैल्यू 5 है तो यहाँ पे 4 हो गई ना, तो अपडेटेड वैल्यू n की 4 हो गई, राइट? यहाँ पर क्या हो गई, 3 हो गई. That's why, okay, you are minus actually 2 times you are doing now. That's why, okay, 2 power n it will be, and it will be log n. Sorry, the space complexity again big O n. Okay, now let's check the next code. So we have here loop also and recursion also. This is a function here. This is one function calling itself, but inside it we are having for loop. Okay, we are having for loop inside it. So this program, this function will go how many times? N times now. But inside it one more for loop is here. Means here this function will call itself again how many times? N times, because n whatever value is 10 times or 10 times, right? Here for loop is also going till your n, right? So obviously it will take n square, no? It will take like this. So first n value is n, okay, n minus 1 and n minus 2. When you will calculate it, you will get n square something value, okay? So the time complexity again become n square. अब now इसका depth कितना जा रहा है, कितने बार your stack will hold that memory n times whatever n value you have, so the space complexity become big O n. All right, now let's check the next code. We have while having value condition as n greater than 0. Okay, so till that time we have to go what, we have to say n times printing n value, okay, and then n divided by 3. So when you are dividing n, first n value is suppose 30. Now you are saying 30, okay, 30 divided by 3, you are saying 30 divided by 3, 10, 10 divided by 9, obviously it will go like that way. 10 divided by 3, not 9, 10 divided by 3, here we are saying n only, no? That's why we are writing n. After this term will become what, this term will become n divided by 27, n divided by 89, like that way it will grow, right? So here you will have, you are again skipping some iteration, that time you have to take care of big O log n, okay? But you are not using any extra space here. These are simple loop variables, right? That you will say space complexity become big O 1. Okay, so this is a simple example of it. Okay, these are very, very simple one. So please check this thing also, and I have already uploaded a previous video as well in this. Please check that video also. Now here the end means this is the last example. Okay, so this is a dynamic memory allocation. You have done this thing also, dynamic memory allocation. We have malloc function, right? As you know, this is a dynamic memory allocation. So time, with the help of, means in this time you can say that allocation of time will be constant. So whenever constant, that means what? As you know, this is a dynamic memory allocation. So there will be a time as in a constant actually. Okay, the time allocation will be what? Constant. So your time complexity become big O 1. Constant hai, whenever constant comes, that means big O 1 will be the time complexity. But what about the space? So whatever the n value you have, that will be the space complexity. So big O n, it allows n number of elements. If you are having n is 100, the 100 space it will take, 100 bytes it will take, whatever it is, okay, whatever the data type you have. All right, so this is a simple example of your dynamic memory allocation also. So whenever you will have that kind of question in a gate exam, maybe you're preparing for any kind of exam, PSU's exam, so that time if they will ask how you can find out the space complexity of the this program and time complexity of this program, that time you simply says what, the loop runs n times, hence the time complexity become big O n. Okay, if the loop runs half time of your n, that time you will say log n, and like that way, if loop working constant time, so big O n will be the answer, right? Space complexity same, if you are not using any extra memory, that time big O 1 will be time complexity. Okay, means it's extra memory use nahi kar rahe ho, that time you will say big O 1 only. Okay, so this is a simple examples of your time complexity and space complexity and how you can calculate it. I have already discussed all points one by one. Please, if you like this video, if you get some kind of knowledge from it, right, it will help you in your future. If it will help you in your future, then yes, please do like this channel and do subscribe to my channel, like this video, and share with your friends, subscribe. Okay, thank you so much. Keep learning, guys, and if you have any kind of doubt, please write in our chat box. I will surely reply. Okay, thank you so much. We'll meet in the next video, and in the next video we will check sorting techniques. Okay, thank you so much.